Hello, this is Leroy Meadows, and in this session, we're going to be doing some exercises related to cost volume profit analysis and cost behavior. So let's go ahead and get started here. In this first exercise, Felix and Company reports the following information, and it's talking about this table right here. Okay, so the first thing we need to do is use the high-low method to estimate the fixed and variable components of total costs, and then two, estimate total costs if 3,000 units are produced. Okay, so whenever doing the high-low method, remember that unlike the scatter plot diagram or the regression analysis, which involve all the relevant data here for units produced and total costs, we're only looking under the high-low method, the highest number of units produced and the lowest number of units produced. So we have this information here in these two columns here. So let's look at the lowest units produced, and that would be period 1 where we produced no units. Then what's the highest units produced? Let's see, and then we go through here, and our highest units produced in the 10 periods here are $3,600. So we're going to look at period 10 and period 1. That's the information we're going to look at here because, again, the high-low method focuses on these two periods. So let's go ahead and in order to do the high-low method, the first thing we're going to do is get a per unit cost for variable cost. That's going to be the very first thing we do. Then step 2 will be to figure out our fixed costs. Out of the total cost, once we have a variable cost, then we can figure out what our fixed costs are. So in order to do the high-low method, to figure out, we have to pick either the one, we're gonna pick out the highest and the lowest level. So we're gonna take, and on the numerator part of our division here, we're gonna take the cost of the highest volume minus the cost of the lowest volume. So the cost of the highest volume is what? We produced 3,600, that was $7,900. So I'm going to do $7,900 minus the cost at the lowest level of units produced or lowest level of activity, which is 2,500. Then I'm going to take that number and divide it by the difference between the highest level of volume and the lowest level of volume. So I'm going to take my 3,600 and subtract for that, that was my highest level of volume here, units produced, and my lowest level of activity or units produced, 0. Okay, so now when I figure out my cost of the highest volume minus the cost of the lowest volume, we're just looking at the differential in cost between the highest level of activity and the lowest level of activity. This cost here and this cost here. And what do I get when I subtract 7,900 or subtract 2,500 from 7,900? I'm going to get $5,400. And that's 7,900 minus 2,500 will give me 5,400. Now let's take a look at the denominator part. 3,600 minus 0, 3,600. Now when I divide 5,400 by 3,600, I will get my variable cost per unit. So let's see, 5,400 divided by 3,600. And that should give me a variable cost of $1.50 per unit. So now that's my variable cost per unit. Now I'm going to look at plugging this back in to either the highest level of activity or the lowest level of activity in order to get my amount of fixed cost. So let's look at the highest level of activity. So I'm going to have my total costs is going to be equal to fixed costs plus my variable cost per unit times the number of units produced. Okay, so my total costs at the highest level of activity is what? 7,900. So I'm going to put 7,900 is equal to my fixed cost plus my variable cost of what? 150 times 3,600. So when I go ahead and compute that out, I'll have 7,900 of total costs will equal my fixed cost plus when I take that 150 times 3,600, that'll give me 5,400. Now algebraically, I just subtract 5,400 from both sides to isolate my fixed costs. So 7,900 minus 5,400 gives me 2,500 is what my fixed costs are. So that's how I'm going to compute my fixed costs. I figured out my variable cost per unit first, and then I can figure out my total fixed costs. So now that I know my variable component and my fixed component, I can now answer number 2. Estimate total cost if 3,000 units are produced. So now I'm not solving for fixed costs, I'm solving for total costs. So my total costs are going to be equal to my fixed cost of $2,500 plus, oops, $1.50 times the number of units I'm producing. And let's say we're producing 3,000 units. So my total cost will be equal to 2,500 plus, and let's calculate that out. 150 times 3,000 is $4,500. So my total cost then will be my total fixed cost plus my total variable cost here, 2,500 plus 4,500 equals $7,000. So based on the high-low method, I can expect my total cost, if I make 3,000 units, I can expect my total cost to be $7,000. So that is the high-low method here. Again, we got to calculate the variable cost per unit by dividing the change in cost from the highest volume of activity and the lowest volume of activity. And then once we figure out that change, we can divide it by the change of the highest volume and lowest volume. That'll give me my fixed costs or my variable cost per unit. And then I can plug that in here to either the high point or the low point to get my total fixed costs. And so my fixed costs are estimated to be 2,500. Then I can use my variable cost per unit and total fixed cost to compute any level of activity. One thing we should note here, and I want to go, let me go over here. And total costs are going to be equal to total fixed costs plus total variable costs. Right? Total costs by behavior are going to be either fixed or variable. If they're mixed, then that's why we need to do the high-low method in order to separate the fixed and variable components. So another way I can look at this total cost equals total fixed cost plus total variable cost is take my total cost equals my total fixed costs plus my cost, my variable cost per unit. Oops. Times the number times the amount of units produced. And that's how I can figure my total costs if I just have my variable cost per unit and my total fixed costs. Then as long as I have my units produced, at what level of activity, then I can figure out my total costs. Okay, so let's go to the next exercise here, 18-7. A jeans maker is designing a new line of jeans called Slams. Slams will sell for $205 per unit and cost $164 per unit in variable costs to make. Fixed costs total $60,000. Now we're asked, compute the contribution margin per unit, compute the contribution margin ratio, and then compute income if 5,000 units are produced and sold. Okay, so let's look at contribution margin per unit first. Contribution margin per unit is simply the sales cost per unit minus the variable cost per unit. So when I take my sales cost per unit, 205, and subtract out my $164 in variable cost per unit, my contribution margin per unit is $41. Now, number two, my contribution margin ratio, I'm simply going to take that $41 and divide it by my sales price. And that will give me a contribution margin ratio of 20%. Now, the third part is compute income if 5,000 units are produced and sold. Okay, so how do we approach this? Well, I'm going to take my sales minus my total variable costs minus my total fixed cost and gives me the amount of income I am going to have. So let me do that real quick. Okay. Put that here. Okay, for whatever reason, I'm having a little bit of a problem here, so okay. So now, let me do this. So sales minus total variable cost minus total fixed cost equals income. So if 5,000 units are produced and sold, how much are going to be my sales? Well, I'm going to take my sales price at $205 per unit and multiply that by the 5,000 units produced. So my total sales will be $1,025,000. So $1,025,000. Now, what are going to be my total variable costs? Well, my total variable costs will be $164 per unit times the 5,000 units produced to be $820,000. And then now we're going to subtract out our total fixed costs, and we're told in the problem here, fixed costs total $60,000. And let me go back in here. Equals total income, or equals income. So when I take my $1,025,000, subtract out my total variable cost of $820,000, subtract out my total fixed cost of $60,000, I will have income of $145,000. And so that's going to be my answer here. Now, there is another way that I could actually approach this. I could actually approach this as total contribution margin minus my total fixed costs equals income. Now, I already know from earlier calculations, my contribution margin per unit is $41. So I could just take my $41 times 5,000 units would give me $205,000. So $205,000 minus my $60,000 of total fixed costs. And let me go back here. When I do that, minus $60,000, my income is $145,000. So I could do it either way. Depending on the facts and circumstances of the question that you're being asked, you may be able to do it this way, or you may just want to do it this way. So it's really up to you, whichever way you want to do it. Just a lot of times the facts or the circumstances or the information provided will determine which method you can use. But in a lot of cases, you can use either method, whichever one is more comfortable for you. So now, let's look at exercise 18-10. Sun Company manufactures a single product that sells for $180 per unit, whose variable costs are $135 per unit. The company's annual fixed costs are $562,500. 1. Prepare a contribution margin income statement at the break-even point. And then 2, if the company's fixed costs increase by $135,000, what amount of sales in dollars is needed to break even? Okay, so let's go ahead and look at and do our contribution margin income statement. Again, we could just do this through a linear formula, but this situation is asking for using the contribution margin income statement method. So let's calculate our sales at break even. Well, we can't really do that first. Now I will plug in my fixed costs here, $562,500. Okay. Now, in order to get how many units I'm going to need to sell in order to figure out my break-even unit, because I have my sales cost per unit and my variable cost per unit. So I need to know how many units I'm going to sell in order to do this. So I need to find out the break-even point. So my break-even units are going to be my fixed costs divided by my contribution margin per unit. So what is my contribution margin per unit? Well, it's going to be my $180 minus my variable cost per unit of $135. So my contribution margin per unit is $45. So I'm going to take that $562,500 and divide it by $45. So $562,500 divided by $45. And in order to break even, I need to sell 12,500 units. So I'm just going to write over here. Let me write over here, 12,500 units. Okay. Now I can do the contribution margin income statement because I know how many units I've sold. So first of all, I'm going to figure out my total sales. My total sales are going to be the number of units sold times the sales price per unit. So 12,500 times $180 is going to be $2,250,000. Now, what about my total variable costs? My variable costs are going to be the number of units sold, 12,500, times my variable cost per unit, which is $135, which gives me total variable costs of $1,687,500. Now, when I subtract out my variable costs for my sales, that'll leave me with contribution margin. So let me go ahead and take my sales, $2,250,000, minus my $1,687,500. And that'll leave me with contribution margin of $562,500. So $562,500 minus my fixed costs gives me 0. So here, the break-even point, this is what my contribution margin income statement would look like. Sales minus cost, getting my contribution margin minus my fixed costs equals income. Now, the second question is, if the company's fixed costs increase by $135,000, what amount of sales in dollars is needed to break even? Okay, so I'm going to approach it a different way for this thing. It's going to be pretty similar though. So my fixed costs already are $562,500 minus my increase in, or plus rather, I'm sorry, plus my increase in fixed costs of 135,000 equals $697,500. Now I could approach this one of two ways. I could approach it by dividing the contribution margin per unit to get the number of units sold and then plugging that back in and redoing my contribution margin income statement over here. But the question is just asking me what amount of sales dollars is needed to break even. Okay, so I have fixed cost is $697,500. What was my contribution margin ratio? Because I can just take this new level of fixed costs divided by my contribution margin ratio, and that will give me the amount of dollar sales I need in order to uh, uh, cover my break-even point. So I can find my contribution margin ratio. I'm going to simply take my contribution margin, 562,500, and divide that by my total sales. So 2,250,000. So my contribution margin is 25%. So now I'm going to take this 697,500 and divide it by my contribution margin ratio of 0.25, and I'm going to get $2,790,000. So $2,790,000. And that's going to be the sales in dollars to break even with the increased fixed costs. Now I can plug that back in if I wanted to, and 2,790,000. What are my new variable costs? We don't know the units, but I do know my contribution margin ratio. So I know that contribution margin is 25% of sales. So I could just take 2,790,000, multiply that by 0.25, and I'm going to get 697,500 here. And so to figure out my variable cost then, to make these numbers add up correctly, I can just take 2,790,000 minus my contribution margin ratio, and my total variable cost will be 2,092,500. Oops. Okay. Now, my fixed cost did increase to 697,500. So again, my balance is 0. So, but this is the amount of sales that we'll need to have to break even with an increase in fixed costs. And I just plugged that back in here in order to show you how it would look like on the contribution margin income statement. When I plug that number back in, it all checks out. Okay, let's take a look at the next exercise. Bloom Company predicts it will incur fixed costs of $160,000 and earn income of $164,000 in the next period. Its expected contribution margin ratio is 25%. Compute the total amounts of expected 1, total dollar sales, and 2, total variable costs. Okay. So in order to get total dollar sales, when we have a target income already included in the problem here, I'm going to add that target income to fixed costs. So what is the amount of fixed costs? $160,000 plus my target income, $164,000, and that's going to be $324,000. So I'm going to put up here fixed costs plus target income, and oops, I want to put a parentheses around that. It's going to be divided by my contribution margin ratio. So I'm going to take that $324,000, and I'm going to divide that by what? Contribution margin ratio, we're told is 25%, so 0.25. $1,296,000. Now my total variable costs. I could do this one of two ways, but I can, well, I know my dollar sales. I know my contribution margin is probably the easiest way to do it. Is my contribution margin is going to be 25% of that, right? So that means out of total dollar sales, $1,296,000 out of total sales, 75% of that will be variable costs, since the other 25% are contribution margin. So I'm going to take that $1,296,000 times 0.75, and I'll get variable costs of $972,000. And this is the easiest way, because you remember, out of the total dollar sales, it's either going to be total variable costs or total contribution margin, one of the two. So if my contribution margin is 25%, that means my variable costs have to be 75% of sales. So that's why I'm just taking the $1,296,000 to get my sales. I got my sales by taking my fixed cost plus target income, adding that together, and then dividing it by my contribution margin ratio. And then I'm going to take that total dollar sales, multiply it by 0.75 in this case, to get $972,000. Okay, let's take a look at exercise 18-22. Now here we have a break-even point with multiple products. Handy Home sells windows, which accounts for 80% of the sales, and doors, which accounts for 20% of sales. So how much ever I sell in units, 80% of it will be window sales. The remaining 20% of my sales will come from selling doors. The selling price of each window is $200, and each door is $500. The variable cost for each window is $125, and each door, $350. Fixed costs are $720,000. First of all, we're asked for the weighted average contribution margin. 2, the break-even point in units using the weighted average contribution margin. And then 3, the number of units of each product that will be sold at break-even. Okay, so we know that, first of all, we need to get our contribution margin for each one. So what is my contribution margin for doors? Well, I sell a door, $500, and the variable costs are $350. So 500 minus 350 gives me a contribution margin of $150 for doors. So $150. And what's my average contribution margin for windows? $200 minus 125, and that's going to leave me the contribution margin of $75. Now, what do doors represent as out of my total sales? How much of them are doors? Well, it says here doors are 20% of sales. So I want to take that 150 and multiply that by 20%, or 0.20. And so we're told that windows equals 80%. Go ahead and, well, do that here. Okay. So I take 150 times 0.20. Now I'm going to multiply both of these out. So I take 150 times 0.20. I'm going to get $30. Then we're going to do the same thing for windows. 75 times 0.80. And that is $60. Now, when I add those two together, my weighted average contribution margin is $90. Now, this is weighted average because this number is going to be more heavily dependent on the percentages that each item represents as a percentage of sales. So now to take my break-even point in units for my bundled products or my sales mix, I'm going to take my, fixed costs are $720,000 and divide that by my weighted average contribution margin. And again, we're using weighted average contribution margin because we have multiple products here. So I'm going to take that $720,000 and divide that by $90. And I'm going to need to sell 8,000 of windows and doors combined in order to break even. Now, this 8,000 only applies as long as doors only represent 20% of my sales and windows represents 80% of my sales. If that sales mix changes, then we're going to have to recompute our break-even point in the number of units sold total and then the number of windows and doors we sell. So, okay, so I'm going to take my total number of units I need to sell, 8,000, and windows represents what? 80% of sales. And what do I get when, and let me just format that real quick. Okay. So out of that 8,000, 80% of them are going to be windows. So assuming this mix, I'm going to end up selling 6,400. I'm going to need to sell 6,400 windows in order to break even. And that's assuming that 80% of my sales comes from windows. Now, out of my total sales mix of 8,000, 20% comes from sales. So when I take my 8,000 times 0.20, I will get 1,600. And just to double check my work, take my 6,400 windows that I need to sell to break even, assuming this sales mix of 8 to 2. Add to that my 1,600, and I've got my 8,000. So that is the number of unit sales of windows and doors at the break-even point. And remember, this is based on this percentage of sales of windows and this percentage of sales of doors. If their sales mix changes to say, let's just say windows represent 70% of sales and doors represent 30% of sales, then we would need to recompute the weighted average contribution margin, and then we would need to recompute everything else, break-even point units, and then break-even point as far as the number of windows sold and doors sold. So this is how we would calculate break-even point in the number with multiple products. We could do that with 2 products. If we have 3 products, then we would just have a third line here to calculate weighted average contribution margin, and then we would have a third product down here for the number of unit sales. If we had 4 products, and we can do it 4 products, 5 products, 10 products, whatsoever, how many ever we need. So, okay. Now, let's get to our final exercise. And in our final exercise, information for 2 companies follows. 1, compute the degree of operating leverage, or DOL, for each company. And 2, which company is expected to produce a greater percent increase in income from a 20% increase in sales? Okay, so we need to compute the degree of operating leverage for each company. So remember that our degree of operating leverage is contribution margin divided by fixed costs. I'm sorry, contribution margin divided by our income. Forgive me. So I don't have that here. So my income for Skittles is going to be what? Contribution margin minus fixed costs. So I'm going to have income of $1 million. So I'm going to take my contribution margin of $3,600,000 and divide that by $1 million. So, and I'm going to get a degree of operating leverage of 3.6 for Skittles. Now I'm going to do the same thing for Starburst Company. Take my contribution minus fixed costs to get my income, and then I'm going to take my contribution margin and divide that by income. So 1,125,000 divided by, what was it, 750,000, and that is 1.5. So now when we look at operating income and degree of operating leverage, what we're going to see here is that the higher the level of degree of operating leverage, the higher the degree of operating leverage compared to a company with a lower degree of operating leverage, the one with a higher degree of operating leverage is going to see the highest increase in net income from whatever percent of sales. So we have a 20% increase in net sales for both Skittles and Starburst. So I would expect that Skittles would have the higher increase. So let's take a look and multiply this by, assuming both of them are 0.20, and I'm going to multiply these numbers out. And I'll just copy this here and make it really quick here. For Skittles, with a 20% increase in sales, this should generate a 72%, and I'm going to restate that as percent, increase in income. Starburst, for 20% of sales, is going to see an increase of 30% of income. So if I do 72, just transfer that over here. Greater increase of sales will go to, or greater increase in income will be recognized by Skittles, even though Skittles and Starburst both have a 20% increase in sales. The higher the degree of operating leverage, the higher the increase in income from an increase in sales. Now, this could work in the negative. Let's say that it was a decrease of 20% of sales. Then, with a decrease of 20% of sales, Skittles is going to lose more income than Starburst. So the degree of operating leverage it works both ways. If I have an increase in sales, the higher the degree of operating leverage, the higher the increase in income. But it also works in reverse, in the negative. The one with the highest degree of operating leverage, if sales decline by, let's say, 10%, then it will recognize a larger drop in income than the company with the lower degree of operating leverage. So that concludes this session. My name is Leroy Meadows. Have a good day.